So we are going to finish up with section 3.3. So we're on to 3.3b. And it's just finishing up with those properties of logarithms. So today we're going to work on taking those logarithms and looking at those properties that we learned in 3.3a. And then we're going to be able to expand logarithms, so that I call them the long form, so it's all written out, and then actually going in just the opposite direction and being able to condense all of those down. So we're going to start with expanding logarithmic expressions. So if we're expanding, we're just making them longer. Right? So expanding logarithmic expressions. Right? So expressions means that there's no equal sign, so we can't solve these guys. We can just, since we're expanding, we can just make them longer. So let's say we have log base 6, and then in parentheses we have 36 over, I'm going to make it fancy, the square root of x plus 1. We're just going to throw it all into one problem. Right? So yesterday, or in 3.3a, we talked about the quotient rule, and the quotient rule had to do with that division, right? And we knew that if we were dividing, that we could actually separate this into those at least two logarithms where you are subtracting. So that's where I start, is I go ahead and I just look at the quotient part, that division part, and then I'm going to separate them. So now I'm going to have log, I'm still going to have base 6, and you always read it from top to bottom. So your first log is going to be the top, which is 36. Since it's the quotient and dividing, we know we need to subtract those logarithms, and then it's going to be log base 6 still again, and then that square root of x plus 1. But we really don't like that little x plus 1 going on there, that square root of x plus 1. So we know that we could actually write that as an exponent. So we would have log base 6 of 36 minus log base 6. And we know that we can write square roots as the exponent of 1/2. So then now we can use our power property, and our power property really only affects this logarithm, right? It doesn't affect the whole thing. That half doesn't go to this guy. It just goes to the one on the right, right? And we know that from our conversation of power properties, or the power rule, that this 1/2 is just going to come out front. So we're going to have log base 6 of 36 minus, that 1/2 comes out to the front, minus 1/2 of log base 6 of x plus 1. And then that's expanded as far as, whoops, throw that other parenthesis around there, don't we? My bad. And I guess really, technically, you don't have to put that parenthesis there. If you want to just leave it as 1/2 log base 6 of x plus 1. I'm getting parenthesis happy, yes. Right? And so they can give you a whole bunch of different types of problems. They can give you like a multiplication one. Like let's say you had log of x squared y. All right? Because you're multiplying those two, we know that that's going to turn into addition. So we would have log of x squared plus log of y. And remember, if they don't put in the little base, we know that then that is a base 10 system, right? You don't have to write the 10 in there, but just remember that if that's not there, that's technically still a base 10 system, right? And then you get that product, or sorry, the power rule again with our x squared. We know that the 2 can come out to the front. So then we have 2 log base 10 of x plus log base 10 of y. So again, like when I go to expand these, I'm trying to look for that nice kind of long line of problems. Right? I want to make sure that I don't have any exponents up here. I don't have any multiplication. I don't have any division. I don't have any, square roots, third roots, or anything along those lines. And then you know that you have expanded totally all the way out, right? And then just the opposite of expanding would be, yep, you got it, condensing, right? So if we're condensing something, we're making it smaller, or we're making it shorter, right? So we can condensing expressions, right? Again, they're expressions, so we can't solve them. We can just kind of make them a little bit smaller and simplify them, but we can never solve what the actual value is. And again, these work for if you're talking about logs or natural logs, it does exactly the same exact thing. So let's say we had a natural log. Let's say we had 3 natural log of x plus 7 minus the natural log of x, right? It's the exact same thing as a log. I mean, when it comes to the operations, we just, because it's log base e, we're just, instead of writing out log base e, we're writing it out as natural log. If it makes you more warm and fuzzy inside, if you want to rewrite it as 3 log base e of x plus 7 minus log base e of x, those two things are completely equivalent, right? If it makes you, if you feel more confident writing them as log base e and not that natural log, go ahead. I am perfectly fine with that, right? All right. So if I want to condense this, I want to have it to where I'm only writing like natural log once in my final problem. So I see that these two natural logs are being subtracted from each other. So I know that that would be the multiplication property. So I know that, I apologize, that would be the division quotient, right? Subtraction is quotient. So, and I also know that my 3 out front, if I think of that power property would be just the opposite. So that's going to become the exponent on there. So I'm going to have the natural log, and then I'm going to have x plus 7 raised to the 3rd, right, using the power property. And that's going to be divided by, because that's our quotient property rule, divided by x. And that is it, right? So on these ones, you're looking to see that you're only writing that log or that natural log once, and then you have your variables and all that good stuff, right? All right, one last one for you. We'll make this one nice and long and fancy just to see if we can get it all figured out. So let's say we have 4 log base 6 of x minus 2 log base 6. Ooh, why is it? 6 of 6 minus 1/2 log base 6 of, I'm going to throw in a y. So I guess I should have said this earlier. I'm all excited for today. When you want to condense all of these, we don't try and trick you, but these bases all have to be the same, right? So those bases all have to be the same in order to combine those, because like ultimately you're having 6 raised to maybe some exponent. So in order to be able to combine those, all those bases have to be the same. We're not trying to trick you. I think all of the problems that are given, the bases are always the same in the book, and just be aware that your bases have to be the same. Before I start the problem, I just kind of go through and do like a little mental check of like what's gonna kind of go on here. I have these subtractions, so I know that I'm going to be dividing, which is nice to know, right? I have numbers out front, so I know that those numbers out front are going to become exponents. And then I'm just going to go with that. And then I know that with that 1/2 being on an exponent, I bet you I'm going to have to switch that to like a square root, but we'll get to that. So when we look at these, we start at the left, right? Just like we're reading a textbook, we're going to start at the left and we're going to go this way. So we know that this is like a division. So we know like this is going to be on top, this guy's going to the bottom. Because this one is also a minus, it's division, you're not having, it's not this divided by this divided by this. This guy is telling you that he's going to be in the denominator as well. If this was a plus, he would be in the numerator, right? We're only really making one fraction. So hopefully in the example it'll make a little bit of sense, right? So a lot of times I try to do more than one step together because I know that that 4 is going to become the exponent. So I know that I'm going to have log base 6, because that's true through all of them. I'm going to have x to the 4th off of that first term. And then when I look at the second term, it's being subtracted, so I know that it's going to be a division. So I got my division. Right? Again, I got my 2 out front, so I know my 2 out front is going to become the exponent. You can either write it as 36 or you can write it as x or 6 squared, and then we can go from there and keep simplifying it. And then on the last one we have that minus, so we know it's division, so we know it's going to be in the denominator. And then I have my 1/2, I know that's going to become my exponent. So I can either write that as y as 1/2, or if I already know that that's going to be the square root, I could simplify it. Right? So then we can just simplify this a little bit farther. What do we have? Log base 6, x to the 4th, we can't simplify any which way, shape, or form. 6 squared we know is 36, right? And y to the 1/2, we know that that would be the square root of y. And that would be my final answer. I'm asking myself, how many times did I write log base 6? I only wrote it once. And then I'm just kind of looking at each one of these factors or these terms just to make sure like they're simplified down as far as they are.